Factoring a sum of cubes. A sum of cubes is a set of terms in which each of the items are perfect cubes and they're separated by an addition sign. In this video, we'll also look at factoring a difference of cubes, which also two cubes, but in this case separated by a subtraction sign. In both of these examples, there's a formula. You can see I've got it listed here already. Don't worry about memorizing this. It doesn't come up very often. It's just important to know that it exists and to look it up when you need it. What I have in the purplish color is going to be our first term, but specifically it's going to be the cube root of that term. So I'm going to find the cube root of each of the terms. The cube root of the first term is 5x, and the cube root of the second term is, I think, 7. Let me check on the calculator. 7 times 7 times 7 is 343. So now everywhere that I see a in my formula, I'm instead going to put a 5x. So 5x will go here. Here, I'm going to square that. So that'll be a 25x squared. Put a 5x here. There's a minus sign in the middle here. And then I'm going to, everywhere that I have the green or I see b, I'm going to put my second term, which is 7. So 7 will go here. This is going to multiply by 7. And then 7 squared is 49. Okay, let's clean this up and write our final answer. 5x plus 7, and then multiplied by 25x squared minus, that looks like it's 35x plus 49. What I want to do next is look at this polynomial and decide whether or not that can be factored further. One of the first thoughts I'm having is this a perfect square? 25 squared is a perfect number, right? And then 49 is also a perfect square. But when I have a perfect square trinomial, the first term, which would be 5x if I took the square root, and the second term, the square root would be 7. When I multiply them together, I actually double them up to get the middle term. So the middle term would have been 70x and it's only 35. So I've convinced myself that this can't be factored any further, and this is our final answer. All right, moving on to the second example. Again, we'll start by taking the cube root of each term. The cube root of 216, let's see, that looks like it's 6. 6 times 6 times 6. So this will be 6x, and then the cube root of y cubed is just y. Like I did in the first example, everywhere that I see the magenta or the purple, I'm going to put the first term, which is a 6x. 6x squared will be 36x squared. And then a 6x here. This is a minus sign. We've got some parentheses. And then everywhere that I have the second term, that green, I'll put y. All right, let's rewrite this. 6x plus y, 36x squared minus 6xy plus y squared. So that's my final answer. Moving down to difference of cubes, the process is the same, it's just that the formula is a little bit different. So we'll start by taking the cube root of each of these items, each of the terms. The cube root of b cubed is just going to be b. And then the cube root of 8d cubed will be 2 times d. I'm going to put b everywhere that I have the purple writing. And I'll put 2d everywhere that I have the green writing. 4d squared. Fill in all my parentheses. Let's see, minus sign, plus sign, plus sign. All right, and then let's simplify this to get our final answer. B minus 2 times d, b squared plus 2 times b times d plus 4d squared. All right, and then for example B, the cube root of 1000x cubed is 10x. And the cube root of 1 is just 1. So I'm going to put a 10x wherever I see a. This will be 100x squared. 100 or 10x. And then I'm going to just put a 1 wherever I have b. That's easy. 1 squared is also just 1. All right, let's see. How does this simplify? 10x minus 1, 100x squared plus 10x, and then plus 1. Again, don't worry about memorizing these formulas. Just know that they exist and know that you can look them up if you need them.